Okay, if I can find my PowerPoint here really quick. There we go. Okay, so we are not going to do all of chapter 11, but we're going to do a little bit. And this is going to be involved in the final. Okay, so chapter 10 and 11, so it'll be about half chapter 10 and 11, and the other half to 60-ish% or so will be stuff you've already done, like chapter 1, 2. So it is comprehensive, but half of it is this newer stuff, this chapter 10, 11 stuff. All right, so chapter 11 is all about water and solutions. And so we're going to get into, like I said, some of it, but not all of it. And water and solutions, just in general, water is so unique and has so many different cool properties about it. Here's some information. I'm going to make that a little bigger. So we use water all the time. For household use, though, it's really only about 2%. Cleaning dishes, drinking and cooking is about 2%. That's what I meant. For cleaning dishes, that's about 6%. Laundry is 11%. Bathing is 23%. Toilets take up quite a bit of water, and then lawn and garden is quite a bit. So this particular slide is just telling you kind of like the difference between surface water and groundwater. So surface water is like your streams, lakes, reservoirs. Obviously, if you think about those are going to have a lot more sediments and bacteria, possible pollutants, because they're exposed. Whereas groundwater is generally a little bit cleaner because it's in the ground. And so there is some pollution, though, from like different waste dumps, agriculture. If you live around here, you probably, there's different farms. There's chicken farms, there's cattle farms, and all of these things have lots of chemicals. They have lots of ammonia, phosphates, things like that. If that gets into your water, it can possibly, be bad. Okay, so this is just showing you some major pollutants. Lead, lead pipes are in older homes. They don't ever make lead pipes in newer stuff, but, we still have a lot of older homes that still have these issues. Chlorinated solvents, these are industrial pollutants. So, whenever we clean water and stuff anyway, we use a lot of chlorination, but if there's too much, then it can cause, cancer. There's obviously some risks that are involved with that. Trihalomethanes, again, this is like a chlorine disinfectant reacting with other pollutants. So, and over here on the right, these are telling you some things that could happen. So you just have to be really careful whenever you're doing it. And we have very, very strict rules on our water treatment plants. PCBs, industrial waste. So also though, you could think of as far as environmentally PCBs, where they're spraying, disinfectants, pesticides and things like that. So much more controlled than it used to be. Back in, the 70s, they were spraying it all over the place, and it was not good. Still to this day, we see some of the remnants from that. Bacteria and viruses, obviously, we have that, going around. These bacterias and stuff can get into your septic tanks, and, with different types of bacterias and viruses can cause different gastrointestinal problems. All right, so some different properties of water, and some of these things we've already discussed. So in previous chapters, the major constituent of living things, so we obviously have water on Earth and we have living things on Earth. Scientists are always looking for some source of water on other planets. They believe that Mars had water based on some of the formations that there are, and, that immediately makes them think that there's some sort of life, or there was some sort of life. So they're constantly looking for that. Water is also considered to be the universal solvent. It dissolves most molecules. It can be a solid, liquid, and a gas. I said that a little too soon, I think, but it is the only thing that does that on Earth naturally. So it has a solid phase that's less dense than its liquid phase, which means that ice floats. Most things, if they were solid, would sink in their liquid state, but not water. It has a very high specific heat. We've talked about specific heat before. Latent heat of vaporization, meaning that it can evaporate, which causes things or helps things to cool. You know, whenever we get hot, we sweat, and we do that because if the breeze comes by, then it will blow on that sweat on our skin, and it will, you know, when your skin's wet, you kind of get like a cooling sensation whenever there's any kind of wind or breeze. And so that's why we sweat, for that very purpose. And then all results from water chemical structure, meaning that, you know, this little H2O structure right here causes all of these cool things. It has this bent configuration. It's also polar, which we've talked about polar before, meaning that the oxygen is super, super negative and the hydrogen end is kind of positive. And they form in all these cool ways. And these bonds between are these hydrogen bonds. And they're super strong, and they can cause really good cohesion. We've talked about that word before too, like where when you spill a glass of water or something, it's just going to kind of stick together. So those hydrogen bonds are pretty strong. Okay, the dissolving process. These are some terms that I want you to know for this final. So a solution is a homogeneous. Homogeneous means that it's like all together. Okay, so one big is all mixed together of two or more substances. Dissolving is the process of making a solution. So we'll get into that in a second. And then here are some components. So you've got solvents, which is present in the larger amount. Solute, which is the thing that's dissolved. So the example that I always give for this is sweet tea. Sweet tea. I love sweet tea. Okay, so whenever you make sweet tea, you have made a solution. So how do you make sweet tea? Well, if I was going to make sweet tea, which I never do because I'm not very good at it, there's a special art to making sweet tea. But whenever you do make sweet tea, you would want to heat the water, correct? Because if you're going to heat the water, then that also will allow the tea to seep. But if you add sugar to it, it causes the sugar to... sugar to dissolve, which makes it a solution. Okay, so what is the solvent? What is the larger thing in sweet tea? I would say the main solvent in sweet tea is water. I'm just going to say water/tea because we've made it into tea, let's say. And then the solute in sweet tea is the sugar. It is the thing that is being dissolved. Okay, so whenever you think about the dissolving process, think about sweet tea or Kool-Aid or, you know, something, lemonade, something kind of like that. All right, I'm going to stop